In this unit, we will be working with radicals, expressions. However, instead of using them underneath the radical sign, we're actually going to be using them with exponents, using radical expressions with rational exponents. Before we do that, we want to refresh our memory on some of the laws of exponents. One of the first laws we have is if we have a variable and we're multiplying it to another one, and the bases have to be the same. Okay. When they're being multiplied, the rule is that you actually add your exponents. So this would be like am plus n. Okay, so whenever we have exponents that are being, or bases are being multiplied together, we add the exponents. Okay, so that's rule number one. The next rule we have is if there is a variable being raised, or has an exponent is being raised, so it's to a power up here. When it's to a power, so it's actually being raised to that on the outside, then this is actually, the rule is multiplying. So I would take the m times the n. So it would be an times m. Okay? The next rule is if we're dividing, so let's say I have am, and that's being divided by a to the n. Okay? Then the same basis, then what we do is subtract the exponent, so m minus n. Okay? And then the next one would be if it's like a and it has a negative exponent, then that means that to get rid of the negative exponent, we flip it, do the reciprocal of it, and change it to a positive. So this would become 1 over a to the m. And if I had 1 over a to the negative m, that would just become a to the m. Okay, since it's negative in the denominator, I still flip it, do the reciprocal, and then I make it positive. Okay, so those are a couple of the properties, and we'll be using these properties throughout this lesson. So just kind of refresher and maybe write that there so you can remember. Okay. Also, one of the other ones, just another one just to state it, is if I have a base to a power and I have another variable there. Okay, like let's say they're being multiplied, and those are being raised to a power. Let's say power of p. Then I'm going to distribute this value to each of the exponents. So then this value then becomes a n times p, and this would be b m times p. Okay? So again, these are properties that you will use throughout this lesson. Okay? So up at this point, we've been dealing with where we've had the index, we've had the radical sign, and then we've had a radicand. Okay? That's the form that we've been using. And what we're going to be doing is converting this index and radical sign into an exponent type form, and then we can evaluate it that way. An example is if I have excuse me, the square root of 25, that is actually can be rewritten with an exponent as 25 to the 1/2. Okay? Where the numerator here is going to be the exponent of this value underneath the radical sign, and then the denominator ends up being the index value outside the radical sign. Okay? So if I had the cube root of 27, I could rewrite that as 27 to the 1/3. Again, the 1 represents the exponent of what the radicand is, and then the 3 represents the index on the outside. Okay? And the same thing with the 4th root of 16, where the numerator represents the exponent that's underneath the radicand, so it's 1, and then 4 is the index of the radical sign, or 1/4. Okay? So by knowing this form, we also could go the opposite way. So if I see 25 to the 1/2, I could rewrite that knowing that this is the exponent of the radicand, so it's like 25 to the 1, and then I do the radical sign, and then the denominator becomes my index. Okay? So if I do the 27 to the 1/3, I have the 27, the 1 again is the exponent of my radicand, and then I do the radical sign, and then the denominator is my index outside. So this is really saying the cube root of 27. Okay? And then on the bottom one here, same thing. It's going to be 16. The numerator is my exponent of the radicand, and then I do the radical sign, and then the 4 becomes my index. Okay? So when we have this form, that is how we can go backwards and forwards. Okay? So let's look at some of these examples and see how we could use them. Okay? So if I have 125 to the 1/3, I could rewrite this as 125, and then I have the exponent underneath the radical sign, which is the 1. I do the radical sign, and then I put the index on the outside. The denominator is the index. So really what I'm saying is, what's the cube root of 125? Okay? At this point, we can look to our chart that we have and look to see if that's an actual value. In looking at the chart then that we have, what I would then look to do is I would go to the cube root column, and I would go down and see if I see any values that might be a cube root. If I see that automatically, I can just jump to what the answer would be. So the cube root of 125 is 5. So I could say, oh wow, look, this really is 5. If I don't see that, then I can do the simplification that we're used to doing in class, in which we break it down. And I could say, oh, 25 and 5, and then 25 is 5 and 5. I'm looking for 3 of a kind, so I know that I have a 5 I can pull out, and I pull it out. So either way, you could do it that way. Okay? Alright, so let's look at the other one. So now we have 5 1/2 times 5 1/2. Alright? Well, let's write this as the radical sign. So this one is going to become 5 is the exponent of 1. The radical sign is a square root, so you can include that there or just do the implied 2. And then you're multiplying that by, again, 5, the exponent of 1, and then you have 2, the square root. So really you're saying the square root of 5 times the square root of 5. Well, we know that to be, okay, the square root of 5 times 5, which is the square root of 25, which is just 5. Okay, so that would be our answer there. Okay? If we didn't see that, you could also do something where when you're multiplying exponents, the rules are to add them, right? So if I do that, I would do 5, I would add the exponent, I would add 1/2 plus 1/2. Well, 1/2 plus 1/2 equals 5 and 2/2. Okay? Well, 2 over 2 is really 1, so that actually equals 5 to the 1, or just 5. Okay, so either way, you could get to it. Okay? Alright, in looking at this next example then, we have 10 to the 1/3 and 100 to the 1/3. So let's rewrite this. So this is going to be 10, okay, to the cube, and it's going to be times by 100. Okay, again, the 1 is the numerator, so that's the exponent here, and that's the cube root. So since I have the same indexes, I'm able to multiply them together, okay? And when I have the same indexes, I can do that. So I can have 3, the cube root of 10 times 100, okay? And so that's going to become the cube root of 1,000. Okay? At this point, I could look to my chart to see if there's a cube root of 1,000 anywhere. And when I come down to the cube root of 1,000, I see that the answer is 10. So I would know that the answer is 10. If I didn't know that, then what I could do is do the breakdown again, where you would do 10 and 100, and then you would do 10, and then you would do 10, and then you see you have 3 10s, because your index is 3. Okay? So I can take 1 10 out, and that would be my answer. Okay? So next, let's move on to, we have 2 1/2 times 2 1/2. So that would be, again, 2 goes inside, the 1 is the exponent, the numerator is the exponent on the radicand. And then I'm going to do square root, and multiplying that by, again, 2, the square root. That then can become the square root of 4 when you multiply them together, and that equals 2. Again, if you want to follow the rules of exponents, you could take 2, since it's the same base, then you could just add the exponents since you're multiplying it. It's going to be 1/2 plus 1/2. That becomes 2 to the 2 over 2, which then just becomes 2. So you can see you have 2 ways that you can get to it. Okay? Alright, in looking at this one here, the next example, we could break it down into where we put into radical sign. So I'm going to have 2, again, the numerator is the exponent to the radical sign, and that's squared. That's an implied 2. I don't need to write it, I guess. Okay. And then that's being multiplied by 8, and that's the radical sign, and then it's squared. So the 1 goes there, the 2 goes there. So I have 2 times 8, the square root of 2 times the square root of 8. That then becomes the square root of 2 times 8, which is the square root of 16. And once I get there, I could look on my chart and say, is there a square root of 16? And there is, and it's 4. So I know that my answer would be 4. If I didn't see that, again, I could do the breakdown of where I do 4 and 4 and 2 and 2 and then circle it and bring it out. So I could do that simplification as well, the factoring. Alright, another thing you could do is you could make the 8 the same base as 2, okay, and then you could then multiply or add all the exponents together. So another thing that I could do, if I want to carry it over here, is I would take this first 2 and 1/2, and I'm going to multiply it by this 8 and 1/2, which really is 2 and 1/2 times 2 and 1/2 times 2 and 1/2. I created the same base because that's going to be 8, 2 times 2 times 2, right? Okay, and when you do that, then you're going to end up adding them all together. All right, you're going to get 2. I'm going to add all those exponents together, so it's 1/2 plus 1/2 plus 1/2 plus 1/2. I would get 4/2. Okay? Well, now I actually have an exponent, or the exponent where the numerator is not 1, but I still know how to rewrite that. So I would rewrite it as 2 to the 4th, okay, because the numerator is the exponent underneath for the radicand, and it's the square root. Well, 2 to the 4th is what? 2 times 2 times 2 times 2 is 16. So that ends up being the square root of 16, and that equals 4. Okay? So you can see there's multiple ways in which you can get to it. You can get to it just by doing it this way, multiplying it, and then solving it. Or if you can change it all to the same base and add your exponents and then solve for it at that point. Okay? So what you want to remember is that the numerator, okay, is the power to the radicand. Okay, the denominator is the index, or root, another word to call it. Okay, so this is just giving you then kind of the verbiage of it. So if the nth root is a real number and m is an integer, then you're going to have a to the 1 nth, so that's like your fraction exponent, equals, and then your numerator goes above where the radicand is, and then your n is your index. And if it's the opposite way, so let's say you have actually a value of m, then the radicand gets the exponent, the numerator, and then n becomes the index. Okay? You also can write it as such. So instead of having the m to the radicand, you actually can just raise the whole thing to that power instead, to that actual numerator, and this actually becomes a lot easier in some situations. So we will look at both ways in which you could do that and realize like which way is the easiest way. So let's get an example on how that might work. So if let's say I have a to the 1/5, okay, I can rewrite that as the radicand of a to the 5th index. So the 5th power, or the 5th root. Okay? If I have a to the 3/5, I can rewrite that as, again, the radicand is a. The numerator becomes the power to a to the radicand, and then 5 is the index. I can write it that way, or I can write it where I do the radicand of a, and again the index is 5, but I raise the whole thing to then the numerator. Okay? So let's look at how we could write this both ways. So x to the 3/5, it would become, you could have x cubed as a radicand, and then the index is 5, or you could do x as the radicand, okay, the index of 5, and then put the whole thing, raise it to the third power. And we'll show you how this works in just a minute. Alright, so now I have y to the negative 2/5. Well, 2.5. And you're like, well, what is that? That's not a fraction. So what you want to do is you want to take your number and make it into a fraction. So 2.5 is actually, 2.5 as a fraction is 5 over 2. Okay? So I could take this and actually change it to be y negative 5/2. Okay? At this point then, I want to follow the properties of exponents. I have a negative exponent, so what do I need to do to make it positive? I want to take the reciprocal of it and make it positive. So reciprocal of that's going to be 1 over y to the 5/2. Okay, so I just, by taking the reciprocal, and then I can change the exponent to be positive. Okay, so now I want to rewrite this. So I could rewrite this as 1 over radicand is y. 5 is going to be the power of the radicand, so that's the numerator. And then I do the radical sign, and then 2 becomes my index. Because it's squared, I don't have to do 2, but if you see it that way better, that's fine. Or I could write it as 1 over, again, the radicand of y squared, and then I'm going to take the whole expression and raise it to the 5th power. So either way is fine. Either the 5th power is to the radicand, or the 5th power is raised to the whole expression. Okay? Alright, so let's look at the square root of z cubed. So now we're going to work the opposite way. We're going to take the radical expression and change it into a fraction, the exponent. So the 3 on the power of the radicand becomes the numerator, so I'm going to have z. 3 becomes the numerator, and then the index is the denominator, so that'd be 3 over 2, so z to the 3/2. Okay? This one here, I have the radicand of b, so we know b is going to be the base, and then I have 2, and it's to the 5th, so the 5th root is always going to be the denominator, and then the 2, what it's being raised to, is going to be the numerator, so I'd write it as b to the 2/5. Okay, so this becomes that, and the index becomes the denominator. So that becomes that, and then the implied 2 becomes that. So it just kind of shows you what the differences are. Okay? So that's kind of changing it backwards and forwards at this point. Again, looking at beginning, we started with the properties of exponents. Make this a little bit lighter, darker. Okay, so this is just something you're going to remind yourself of how to work with exponents. We talked about how you can change the radical expressions into a exponent fraction. Okay, and that how you can, once you go from the radical fraction, rational fraction, you can then put it into your radical expression and then simplify it. We talked about how you can change that into radical expressions and then define your answer, or you could use the properties of exponents and find your answer that way. And then we just demonstrated how to go backwards and forwards. So I can go from the fraction exponent into the radical expression, or I could go from the radical expression into a fraction. Okay, so those are the kind of things that we covered. Okay, as we turn the paper over, now we're going to look at ways of simplifying by rewriting them and then seeing if you can simplify them anymore. Okay? So at this point we have a negative 32 and it's raised to the 3/5. So I could rewrite this as negative 32 is my radicand. Okay, the 3 becomes my exponent to the radicand, and then I have the radical sign and I have it to the 5th power. Okay? As the index. Or remember, we have two ways that we can write this. I could do the negative 32, and I'm going to take it to the 5th power, or to the 5th index, and then I'm going to cube it. Okay, so I can have the power of 3 to the 32, or I can have it to the whole expression. Now, the reason why this becomes an easier way than this This is a lot easier to find the fifth root of a number and then cube it than to cube a large number and then take the fifth root of it. So if you're just looking at your calculator and trying this out, I'll show you how that is. So if I want to take 32 and cube it, so I would do negative 32 and I would raise it to the third power, I'm going to get this large number, so I'll write this down. Negative 32,768. Okay? And now I want to take the fifth root of that. So I need to actually take the fifth root of a number of negative 32768 and hit enter, and I should get negative 8. Okay? So that was fine, but it's a large number, and then you take the fifth root, and it's just a lot easier then to say, okay, well, what's the fifth root of negative 32? Well, negative 32, the fifth root is negative 2, okay, so this is negative 2, and that's raised to the third power, and then negative 2 raised to the third power then is negative 8. Okay? When I did this one, negative 32 to the third power was negative 32,768, and then I take the fifth root of it, okay, and then the answer is negative 8. So in the end you get the same answer, so you can decide which one you like better, but usually when you're dealing with numbers, doing it in this format is better. Doing it in the a square root of like n, all raised to the m power, is the better format. Okay? Alright, so let's look at the next one here. So we have 4 to the negative 3/5. So again, we need to take this negative 3/5 and make it into a fraction. So negative 3/5 is going to be a negative 7/2. Okay, so this really can be rewritten as 4 to the negative 7/2. Alright, so looking at our law of exponents, we don't want a negative exponent. So I want to take the reciprocal of this and make it positive. So this becomes 4. Oh, sorry. This becomes, I have a trail eraser, 1 over 4 to the 7/2. Okay? So now I can rewrite this, and I can go two different directions with it. I can go 1 over 4 to the 7th power squared, okay, because the 7th becomes the power here and the 2 becomes the radicand, or the index on the radical sign. Or I could do 1 over 4, the square root of 4, and that's all going to be to the 7th power. Okay, so either way they're the same. Now I could then, on my calculator, go 4 to the 7th power and get a number that's 16,384, which then I need to take the square root of it. It's 1 over that. Or I could do 1 over, well, what's the square root of 4? Well, it's 2. So this becomes 2 to the 7th power. So I have 2 to the 7th power, and that equals 128. Okay, and that's 1 over 128. Now if I take the square root of 16,384, I should get 128, and I do. So you get the same answer regardless. Okay, so it's just which way do you like it better. Again, I think this is the better way when you're dealing with numbers. Okay, looking at, kind of go off here, 25 to negative 3/2. Again, to make it the rules of exponents, we want to put it 1 over reciprocal to the 3/2, and then I could rewrite this. I could do 1 over 25 cubed, take the square root of it, because the square root becomes the index and the 3 is to the radicand. Or I could do 1 over the square root of 25 and then raise it to the numerator. When I do this, this one is easy. It's going to be the cube root of 25, or the square root of 25, which is 5. So then this becomes 1 over 5 cubed. which is 1 over 125. Okay? On this one here, I'd have to take 25 cubed, so I'd have to go 25 raised to the third power, and 25 raised to the third power, and that's going to be 15,625. So I'd have 1 over 15,625, and then take the square root of that. And so if I take the square root of that, the square root 15,625, I will get 125. So again, 1 over 125. So I'm going to get the same answer regardless. Just realize either way works. Okay? Alright. So what I'd like you guys to try and do is to try and do this one here on your own, the 32 6 to the 5th. Try this one on your own. Go ahead and stop or pause and then work it, and then when you're finished, go ahead and start again. Alright, so if you've tried this, hopefully you broke it down to the following either way, where you have 32 to the 6th power and you're taking the 5th root of it, or you're taking the 5th root of 32 and then you're going to raise it to the 6th power. Okay? If I do the 32 to the 6th, I'm going to get an increasingly large number that then I have to write down, remember, and take the 5th root of it. Or, if I do it this way, I take the 5th root of 32, which if you look at your sheet, I would see if that exists, and it does. And the 5th root of 32 is 2. So I'm just going to write 2. This becomes 2, and that's raised to the 6th power. Okay? And then 2 raised to the 6th power is 64. So this becomes 64. If I took this very large number and took the 5th root of it, it would also be 64. So I think you can see how one might be a little bit easier than the other. Okay? Alright, let's look at this one. Let's try the negative 81. Negative 81 is going to be negative 81 to the 5th power, and you're taking the square root of it, or you're going to do negative 81 square root, and then you're going to raise it to the 5th. Okay? Well, right now, just looking at it, and basically what we know about negative numbers and even indexes, what do we know? That's not possible. We're going to get a negative number underneath the radical sign, and at this point in time, that is not a possibility in this class. So therefore, this is a no solution. Okay, we cannot have a negative number with a positive or a even root. So 2, 4, 6, 8, whatever. You cannot have a negative number. Okay, so therefore that's a no solution. Okay? Alright, so now we're going to try another example, and this one is going to be using another principle of our exponents, our properties of exponents. So we notice that we have 8x to the 15th, and that's being raised to negative 1/3. Okay? So what we want to do is, the first thing we want to do is get rid of this negative, use the properties of exponents with that. So we're going to put everything over. So I'm going to do the reciprocal, so it's going to be 1 over 8x to the 15th, and that's all to the 1/3. Okay? So again, when you have a negative exponent, you do the reciprocal and then make the exponent positive. Okay? At this point, I'm going to use the property that we talked about where we have something raised to the power, and this power then gets distributed to each element. Okay? So I'm going to do, I have 1 over, I'm going to do the 1/3 to the 8th, so I'm going to have 8 to the 1/3, okay? And I'm going to do the 1/3 to the 15th, so I'm going to have x, and again, because it's to the power, I multiply, so it becomes 15 over 3. I can then reduce, see if I can reduce anything. I can, at this point, reduce the 15 divided by 3. That can become 5. So I can actually write this as 1 over 8 to the 1/3, okay? And then this can become x to the 5th. At this point then, I can then go ahead and put it into the radical expression. So I'm going to have 1 over, okay? I have 8 to the 1/3. That's a fraction. Because it is a fraction exponent, I want to rewrite that as the cube root of 8 times x to the 5th. Okay, so only the 8 is under the radical sign, and that's the cube root. Okay, well, what's the cube root of 8? The cube root of 8, you then try to simplify it, and if you look right here, the cube root of 8 is 2. Okay, so I can then simplify this cube root of 8 to be 2. Kind of going off here, so that's going to equal 1 over 2 x to the 5th. Okay, so only the 8 to the 1/3, because it is a fraction, does it get changed into the radical expression. And then you want to simplify as best you can, because 15 divided by 3 here becomes 5. That is no longer a radical expression. And if I did it that way, if you notice, let's say it is x to the 5th, and you're like, well, I want to change that to a radical expression. Well, you could. Okay, so this is the numerator, so that's really like x over 5 to the 1, right? Well, x, you would raise it to the power 5, but then 1 is your index. So there is no root. There is no radical expression. When it's just 1, it just goes away. So that is really converting it that way. Okay? Questions on that? Alright, in looking at the rest of the problems, I'm realizing that this worksheet you guys have is not, we don't want to do the rest of the problems. So you can just go ahead and cross these out here. You don't have to worry about that. And what I'd like you to do, you can either use the space on this page here that's left over, or you can get a pause and just go get a blank sheet of paper. So I'm going to give you additional problems to work on then, okay? So the first one, so go ahead and pause if you want and change and get a new piece of paper or start it. But the first problem we're going to do now is we're going to do where we have, hold on real quick, where we have x times, or x to the 1/2 times x to the 2/3. Okay? So go ahead and write that problem down. Alright? And this is really where we're going to be using our rules of exponents first. Okay? So we have two the same base, and they're being multiplied together, and they have exponents, and the rule of exponents, so we want to add them. Okay? Well, so really what this becomes is going to be x, and it's going to be 1/2 plus 2/3, because that's the rule of exponents and multiplying as you add them. You can find at this point in time that the only way to add these two exponents together is actually creating a common denominator. So a common denominator between the 2 and the 3 would be 6. So I'm going to multiply this by 3 over 3. I'm going to multiply this by 2 over 2, and then I'm going to make them a common denominator. So this ends up becoming x, and this 1/2 then multiplied by 3 would be 3 over 6. And then multiplying it by, or it's being added, sorry, it's being added to then, this one when I multiply by 2 would be 4 over 6. Okay? So again, I'm just multiplying by the 1/2 by 3 over 3, and I'm multiplying the 2/3 by 2 over 2. And at this point then I can add the exponents. This allows me to add them. So it becomes x to the 7/6. At this point, I'm able to then create a radical expression to it. Now, if you notice, my base, or my radicand, is a variable. So we have two options here. Again, we can break this down where we say x to the 7th power and then take the 6th root of it, right? Or I could do x, take the 6th root of it, and raise it to the 7th power. Okay? So now we have those two situations that you can do. Notice though, if I have a variable as my radicand, this format, where it's the radicand to the power, is really the best option versus this format. Because it's a lot easier for me to simplify x to the 7th. I can do that, take 7 divided by 6, I can pull 1x out and have 1 underneath it, right? Because I need 6 of a kind, so 1x gets pulled out, and then I'm left with 1x underneath. That is way easier to reduce it than coming here, because I don't have anything I can pull out, and I gotta raise it all to the 7th power. So I have to do the 6th root of x times 6th root of x, and you go on and on and on. And so that becomes really complicated. So when you have a variable as your radicand, this format is really the best. Okay? So that would be your answer. That's to the 6th. Okay. So let's try another example. Alright, let's go ahead and write x squared and have it divided by x to the 3/5. And again, you're probably thinking, oh great, I hate fractions as it is and now I'm dividing it. It's all good. We get there, okay? All we got to do is follow the rules of exponents. So again, stick with what you guys know. Don't see it and freak out or anything. Just be like, okay, I have 2 of the same base that I'm being divided by. The rule of exponents when I'm dividing is subtraction. So I'm just going to set it up as a subtraction problem. So I have x, I have 2 minus the denominator, which is 3/5. Okay? So now all I got to do is make this 2. I have to have the common denominator in the exponent, so now I just have to change that. So I'll multiply by 5 over 5. Okay, so then this becomes x 10 over 5, because all I do is multiply by 5 over 5. Right, 5 times 2 is 10, and that's like over 1. Remember, it's like a whole number is like over 1. And that's going to be minus 3 over 5. So now I can subtract those, right? You can subtract that, and that becomes x 7/5. Okay, so now I can then change it into my radical expression. So I have x to the 7th, the radical sign, and then it's to the 5th. So now I see that I can take 5 out of, I need 5 of kind to pull an x out. I can pull out an x, and I'm left with 2 underneath the radical sign. Okay, if you don't see that, then what you could just do is divide 7 by 5. So take 7 divided by 5. I'm left with 1. Okay, and I have a remainder of 2. So the 1 is what I can pull out, and the 2 is how many I stay in. Alright, so let's try another problem. Let's do 16 y to the negative 8, and that's raised to negative 3/4. Okay? Again, don't freak out, just follow the rules of exponents that you know. First of all, we have a negative exponent right there, and we don't like negative exponents, do we? So what we want to do is get rid of the negative exponent, and we need to do the reciprocal of it. Because everything is being raised to that negative exponent, everything gets then reciprocated. So this becomes 1 over the 16 y to the negative 8. That stays negative 8 because you haven't changed that one yet. You've only changed the 3/4 to the 3/4. Okay? So at this point, what we can do is we can go and distribute this 3/4 to each element. So let's go ahead and do that. So I'm going to take 1 over. I'm going to take 16 to the 3/4. Okay, so I'll do 16. I'm just going to take this power and multiply it there, so it's 3/4. Okay, and then I'm going to take the 3/4 and multiply it to negative 8. So I have y. Okay, so negative 8 times 3 is negative 24. Negative 24 divided by 4 is going to be negative 6. Okay, so again, this is like 8 over 1, so the 8 times the 3 becomes 24 divided by 4. The negative sign becomes negative 6. Okay? At this point, then what I would do is get rid of any other negative exponents I have. So this y to the negative 6, I can make positive by making a reciprocal. So I could then rewrite this as y to the 6, again reciprocal and make the positive, over 16 to the 3/4. Alright? So at this point, my y to the 6 stays y to the 6, and I'm going to look at my exponent that I have here. So I'm going to make this radical expression. That's going to become 16. Okay, I'm going to take the 4th root of it first. Okay, so remember the denominator becomes the root, and then I'm going to put everything, I'm going to raise it to the 3rd power. Because again, when it's a number, it's easiest if you take everything to the power. So I'll take the 4th root of 16 and take that cubed root of that. Well, let's see if we have a 4th root of a 16. So I look here on my sheet. I have 16. I do have a fourth root, and that root would be 2. So the fourth root of 16 is 2. So then I could rewrite this as y to the 6th all over 2 cubed. So 2 cubed is what? It's 8. So this becomes y to the 6th all over 8. Okay? Alright, so now what I'm going to have you do is I'm going to have you write down a couple more problems to have you try on your own. And then when you're done trying them, go ahead and pause after you write them down, and then try them, and then start the recording back up. So the first problem to try on your own is going to be, in parentheses, 8x to the... Oh, I already did this one. Okay, so I already did this one, so forget this one. Let's try this one. Let's try x to the 1/2, and that's going to be divided by x to the 1/3. Okay, so it's very similar to this one right there. Okay, and the next one to try is going to be x to the 4/5, and you want to multiply that by x to the 5/2. Okay, so go ahead and try that one. Pause it and then come back. Okay, in looking at x to the 1/2 over x to the 1/3, that's actually very similar to the one right above it as well. You could have used that one. Okay, they're being divided, so you're going to actually subtract your exponents. So I'm going to have x to the 1/2, and I'm going to minus the 1/3. Okay, the bases are the same, so I can subtract their exponents. So I need to get a common denominator, so it's going to be 6. So I'll do x, to make this a 6, I multiply by 3, so it's going to be 3 over 6. And I'm going to subtract then, multiply by 2, it would be 2 over 6. Alright, so when I'm done, 3 minus 2 is going to be x is 1 over 6. And then that can get rewritten as x to the 1 power and then to the 6th root. So that would be the way that it would go. Okay. Alright, so looking at the next problem, we have x to the 4/5 times x to the 5/2. Again, if you haven't tried this one yet, pause and then come back and check your answer. So at this point, I am multiplying exponents, and the rule of multiplication is adding. So I'm going to do x. I'll have 4/5 plus 5/2. I need to get a common denominator for both, so I'm going to do 10. So I'll multiply this by 2, and that's going to be 8/10. And then I got to multiply this by 5. It's going to be 25/10. And that's x. So at that point, I'm going to add them. So I'm going to have x to the 33rd tenth. Okay. So I would then do x, take the 10th root of it, and then raise it. Oh, actually, no, you don't want to do it this one. You want to do x to the 33, okay, and then take the 10th root. So we look for 10 of a kind. So how many 10 of a kinds do we have in here? We have 3 10 of a kinds. Okay, so if I do 33 divided by 10, it goes in there 3 times, and I'm left with 3 over. So I'm going to pull 3 x's out, and then I'm left with 3 x's in. Okay, and don't forget your index up here, and that would be your final answer. Okay, so at this point what you'd want to do is you want to go ahead and go to the homework sheet that we have, page 261, and you're doing 21 through 49 odd. Okay, and again, go back and revisit these. Try these examples again if you need some extra help.